So they do give you some bounds here. They give you the -1 to 1. However, you still have to go through the points of intersection thing and see if you ever cross in the interval between -1 and 1. So you would set them equal. You'd have e to the x equals e to the -x. And again, you have a common base there. So you can just cross out the bases and say x is equal to -x. Now, if you look at that, you kind of know the only answer could be 0. However, if you move everything over, so add x to both sides, you get 2x is equal to 0, which gives you x is equal to 0. So there's actually two intervals here of interest. You're going to start at -1. You're going to go to 0, integrate there with a big minus small, and then you're going to go from 0 to 1. Okay, so we have to kind of compare for each of these intervals. So for the first interval, we have our two functions, e to the x, e to the -x, and for the first one, we might plug in, let's say, -1/2. Okay, so you'd have e to the -1/2, and then for the other function, you would get e to the +1/2. Okay. So what you're looking at here is e to the 1/2 versus e to the -1/2. Keep in mind that this is, of course, 1 over e to the half. So the bigger function here is going to be this e to the -x. So the big function will be e to the -x, and then minus your small function of e to the x. So to keep this straight, on this first interval, you're going to be integrating e to the -x minus the small function of e to the x. Okay, then you have to repeat that process for the second interval. So obviously it's going to be flip-flopped, but to see that for the second interval, you would look at y is equal to e to the x, y is equal to e to the -x, and plug in 1/2, +1/2 now, and +1/2. Okay, and when you do that, you now get that the big function is e to the x, and the small function is e to the -x. So on the second interval, you would have e to the x minus e to the -x. Okay, so again, it's two intervals because you do have you have a point of intersection in the middle there. Okay. So here's what it's going to look like. You're going to have an integral from -1 to 0, where your big function is e to the -x minus e to the x, and then of course dx, and then plus the integral from 0 to 1, e to the x minus e to the -x dx. Now, my battery is a little low, so just to kind of quickly talk about this, for this first one, you are going to have to do a u substitution, and that is going to give you e to the -x over -1 when you do the u sub. Minus e to the x is just going to go to the e to the x. Okay, then you add that, same idea over here, the e to the x stays. Here you would have to go through a u sub with u being equal to -x, and that's going to give you negative, and then this will integrate to e to the -x over -1. And then you'll plug in 0 to 1. Okay, so I would simplify this first. Really what you're looking at here is negative e to the -x minus e to the x from -1 to 0, and then plus e to the x, and then plus e to the -x from 0 to 1. Okay, so plugging in first, upper bound minus, okay, so that's my upper bound, minus, and then my lower bound, okay, and then I'll have to add that to my upper bound plugged in here, oops, plugging in 1, and then minus my lower bound plugged in, and I'll put all of this in as a plus e to the 0 plus e to the -0. Okay, so I have my upper bound minus lower bound plus upper bound minus lower bound. Now, when you simplify this, you are going to get -1 because you have e to the 0, which is just going to go to 1, and then minus, again, an e to the 0 goes to 1, minus negative e to the positive 1 minus e to the negative 1. Then you add that e to the first plus e to the negative 1 minus, and then these both go to 1, so you're looking at minus 2. Okay, so if you combine all your like terms, you're going to have negative 1 minus 2. That's going to go to negative 4. And then you'll distribute this negative, so it's going to go to a plus e to the negative 1 plus e to the negative 1. And then combining those like terms, you have negative 4 plus e plus another e will give you a 2e, and then plus e to the negative 1, e to the negative 1 gives you 2e to the negative 1. Okay, now you can go further there just like we were able to go further in the previous problem. And again, if you just want to leave your answer like this, that is fine. But you could remove your negative exponent. So you would have this plus 2e. And then from there, once you remove your negative exponent, you would get a common denominator. And that common denominator would be e. So you'd multiply in here by e over e over e, and then that has your common denominator. So this would give you negative 4e plus 2e squared plus 2 all over e. And then rearranging, you have 2e squared minus 4e plus 2 over e. And this is also a perfect square trinomial. And because it's perfect square trinomial, even before that, you could just take out a 2. And then you'd have e squared minus e plus 1 over e. And then you can factor this and say, okay, this is going to be e minus 1, and then e minus, and this needs to be at minus 2 minus 1. And then that's going to be over e. And then that will give you 2e minus 1 quantity squared over e. But all of this work here about getting the common denominator, factoring it, you do not need to really do that in order for it to be okay.